let's compute with scientific notation. Now, what we have here is the multiplication of two numbers written in scientific notation, and we're going to refer back to that multiplication of monomials that we did before. And when we see this here, what we literally have is the multiplication of these two numbers and the multiplication of these two numbers. So what we have is like 4 different multiplication problems happening here. So if I was to go over here and just write 2 times 3 times 5 times 7, we'll say, right? I can rewrite that to say 2 times 7 times 3 times 5. I can reorder that because of the commutative property and because it's multiplication. So what we're going to do is we're going to do the same thing here, is we're going to take those number bases and we're going to multiply those together. So I've got 6.2 times 1.1, that's one part. Then my other half is going to be 10 to the second times 10 to the fifth. Now I'm going to take the x out of there for now, and I'm going to use a dot. Okay? And then we just multiply. So let's do 6 times 2, or 6.2 times 1.1. Let's bring in some green here. I got 1 times 2 is 2. 1 times 6 is 6. Some purple. I annex a 0 because technically we're multiplying by 10 here, not by 1. 1 times 2 is 2. 1 times 6 is 6. Now when I add these together, 2 plus 0 is 2. 6 plus 2 is 8. 6 plus 0 is 6. Now, go back to, this is your 6th grade work now. We count the number of decimal places. I see 1 decimal place here. I see 1 decimal place here. So I'm going to move this 2 spots and say the answer is 6.82. So I've got 6.82, and that satisfies our rule that that number has to land greater than or less than 1, or greater than or equal to 1, less than 10. So that's successful there. Now, 10 to the second times 10 to the fifth. Let me go to the side here with the red. Remember how to do this? This is 10, and because we're multiplying like bases, similar bases, we can add the exponents together. So 10, 2 plus 5, which then is going to give us times 10 to the 7th. And that's our answer. So take the bases here, multiply those together, make sure your value lands between 1 and 10. 1 or greater, 10 or less. I'm going to get this. And then because you have like bases, you can add those exponents together to get the final exponent. Now let's try division real quick. Let me erase this. Yoinkerdoo. And for division, I chose something that's just a little bit more difficult too. So we get an idea of what we want here. 1.14 times 10 to the 6th divided by 4.8 times 10 to the negative 5th. Now this gives us a good opportunity to practice some skills that we had previously, and that's the division with decimals here. So what we see here is we see 1.14 divided by 4.8. And now if you remember this, we cannot have a decimal in our divisor. So what we're technically doing is multiplying both of these by 10 to move the divisor, to move the decimal over one space so that there's no decimal in the divisor. And when I do that, just for my sake, I want to remember I'm going to put a dot there. And that way I can remember that that's where the decimal place is. When I do this division first, 48 into 114. Now, I don't know the answer, but I do know how math books work. I know that there are 0 48s in 11, so I'm going to put my 0 there. Now, when I look at this now, I think, okay, I need a 4 in the ones digit. I'm going to multiply 8 by something to get a 4 in the ones digit. 8 times 2 is 16. 8 times 3 is 24. So I'm going to try 3. If I look back here, 3, 24, carry the 2, 3. No, it's going to be way too big, right? So let's try 2. Let's just do 2 here. So that gives me 16, carry the 1, and then 9. So I need to borrow here. Let's make that a 0. That's an 8. 10 minus 9 is 1. 0, bring that down. 180. 5 would be too many because 5 times 4 is 20. What about 4? 4 is too many because 16 plus 3. So let's do 3. 3 is 24. Carry the 2. 12. 144. That's going to be 7. 10 minus 4 is 6. 7 minus 4 is 3. Annex is 0. Let's bring that down. 360. I'm going to try 7. 7 times 50 would be 350, so let's do 7. 756, 5, 28, 33. So 5, 10 minus 6 is 4. 240. All right, should we try our 5? I think here we're at our 5 right now, and I'm running out of space. 5 would be 4. I'm going to write small. 40, carry the 4. Yes, 24, 0. We got there. Whoo, that was close. So we have a base. It's 0.2375. All right, now over here, this should be a little bit easier because we're using our products, not our products, our quotient of powers. So I have 10 to the 6th divided by 10 to the 5th, and we can rewrite that as 10 to the 6th minus whatever that denominator is, negative 5. Which means now we've got 10 to, this becomes 6 plus 5, 10 to the 11th. So x times 10 to the 11th. Okay, now alarm bells should be going off right now, right? So you're looking at that going, wait a minute, something's not right with that, Mr. Romanovich. And you're right, something's not right with it. The number that we have here right now does not satisfy our criteria for scientific notation. It is not 1 or greater and less than 10. It is less than 1. So we have to manipulate the decimal a little bit here and make this correct. So what we're going to end up doing is taking this decimal and we have to move it one step that way. So we multiply this side by 10, which means we have to do the same for the other side too. Multiply that by 10, which is going to change this to 2.375 times 10 plus 1 to the 12th. And that is our answer. 2 more computations for working with scientific notation. Let's add 2 of these together, and then let's subtract 2 of them together. Now, key for this when we're adding and subtracting is that we make sure that our base we're not worried about. It's this exponent. Our place value has to be the same in both of these. So we have to change the place value of one of them to start. When we look at this, I've got 9.5 times 10 to the 10th equals, or plus 10 times 10 to the 9th. So we have to make this one 10 to the 10th, or this one 10 to the 9th. I'm going to make this one 10 to the 9th. So to make this 10 to the 9th, we're at 10 to the 10th now. We need to take one of those powers out of that. So we're going to make this a little bit smaller. What it's going to make this into is 95 times 10 to the 9th. Now I know technically we're in illegal mode here, right? That number does not fall between 1 or greater, less than 10. But in order for us to add these together, we need to get the place values correct, times 10 to the 9th. And then we can adjust it at the end. Wow, a lot of slope writing here. And I'm really getting hot. I'm going to turn the air on. You know what you don't want to see? You don't want to see me sweating. Oh, that's good. They've turned the air off here in the building. Can you believe it? All right. Okay, so we're then, right? So we're just going to add these together now. 10 to the 9th and 10 to the 9th, that's just going to end up being 10 to the 9th. That's fine. Now we got 95 plus 5.7. Now in my head I know that's 100.7. But just as a reminder, let's not forget that when we do something like this 0 here matters. So this really is 95.0 plus 5.0. And when we add decimals, we always line them up. So that's going to give us 100.7 times 10 to the 9th. Now for an answer though, we need that answer to fulfill that parameters there. So let's make sure that that works. we need to move this decimal place 2 spots, 1, 2, which is going to give us 1.007 times 10. Are we representing a big number? Yes. So we're going to increase this by 2 by 10 to the 11th. Subtraction. Okay, subtraction is this one here. And again, what we have to have is we have to have like exponents for our scientific notation for this to work together. So what I'm going to do is I'm going to leave this one here as 2.19. So I've got 2.19 times 10 to the 8th. Now I need to turn this into 10 to the 8th, which means I'm going to move that decimal place 2 times to the left. So this is going to go 1, 2, not very teachery of me to write it right on the problem, but let's rewrite it down here. So we're going to have 0.057 times 10 to the 8th now. Okay, so when we do this, we know what we're going to end up with here is 10 to the 8th, right? That's going to happen. Now for this one, let's annex this 0 here so that we have 1, 2, 3 spaces and 1, 2, 3 spaces. Let me just yoink that out of there too so we don't have to see it. So I have 0 minus 7. No, that's not 7. Don't forget that. I mean, we've got to borrow here from that. Or ungroup. Some people say ungroup now. Let's say 8. 10 minus 7 is 3. 8 minus 5 is 3. 1 minus 0 is 1. 2 minus 0 is 2. When we add and subtract decimals, that decimal gets lined up and comes down there. Does our base value here fall between 1? Is it 1 or greater and less than 10? I'm going to get that right eventually. Yes. And then we have 10 to the 8th, and then that's our answer. Pretty simple, okay? So for a multiplication and division, let's review real quick. Multiplication and division. I'm going to do this real quick. I'm not even going to pause it. We're just going to watch me erase. So multiply, divide. Multiply, divide. We are going to multiply / divide bases and notation separate, right? For add and subtract, we want like, oh that's not like, that's line, like notation so that our exponents are the same. Yeah, so don't forget too that your answer has to fall within the parameters of scientific notation. That means 1 or greater and less than, I wrote the 1 horizontally, less than 10. Good luck.